All right, welcome. This is a quick screencast to go over and to prepare you for tomorrow's quiz. We went through the front side in class, but for anybody who needs to jog the memory, this is a recent survey of a sample of 121 teenagers revealed that 45% of teenagers prefer their pizza with pepperoni. Of course, based on that spelling, we found out that this pizza topping is actually a pepper, similar to a bell pepper, not the actual Italian meat. All right, identify any assumptions. You should be thinking about the 10% rule, that there's a random sample. It doesn't say it, so you have to assume it's a random independent sample, and then prove that you can have 10 successes and 10 failures, which is this 45%, the p hat, which means 55 would be q hat, and our n 121. All of these check out just fine, so we proceed with a normal model. 2, construct a 95% confidence interval for the true proportion of all teenagers who prefer pepperoni on their pizza. You should be familiar with p hat plus or minus the critical value times your standard error, p hat q hat over n. Once you fill some stuff in, should be familiar, 45% as our p hat plus or minus 1.96, which we take that because of 95% confidence. Plug in your standard error, and you should be between 36% on the low end, 54% on the high end of your interval. Explain what 95% confidence means in this context. I'll say two things. First, the best thing you should say is that we are 95% confident that the true proportion of all teenagers who prefer pepperoni is between 36 and 54. And then I'll also add, what does 95% confidence mean in general? Not in this context. 95% confidence means that if you take interval after interval after interval after interval after interval, same size samples, it means that 95% of those intervals will catch the true population proportion. 4 is a tough one. What is the probability that the true proportion of all teenagers who prefer pepperoni is within the confidence interval? It's not 95. It's actually 0 or 100%. You take a sample of a p hat, and you have a high end and a low end. So the thing is, this is not asking about this at all. It's asking about the true p, true proportion of all teenagers who like pepperoni on their pizza. So that p is either in that interval or it's not. It doesn't move. What moves is our interval. Our interval moves based on sample to sample. One sample, it might be high. One sample, it might be low. Sometimes it catches p, sometimes it doesn't. But p does not move. Or you could just remember this answer is either 0 or 100, not 95. Another recent survey with the same sample size showed that 55% said pepperoni. Is that unusual, or is that in line with what we expected? We should think it's a little unusual because 55 is outside of the interval of 36 to 54. We're expecting anything from 36 to 54. If another sample says 55, that is not in line with what we were thinking or predicting. Number 6, create a new confidence interval for the original proportion. It was 0.45. That 72 is a typo. With 80% confidence level. The only thing that changes here is our critical value. So our critical value is our z star for 80%. Think about a normal model centered with the 80% in the center. That means you'll have 10% in the tail. So use the calculator. Inverse normal. The only thing you're asking is the z-score for the 10% tail. Z-score, so you'll keep 0 in the center, 1 is standard deviation. I believe it's going to be 1.28. That's the only thing that changes. You'll still have the same p hat 45. You'll have the same standard error here. Plug all that in. Your new interval would be from 39 to 51. So as you've lowered your confidence level, you've actually gotten a tighter margin of error than what we had up there. 36 to 54 would be wider than 39 to 51. You drop confidence, you have a smaller margin. So 7, what are the advantages and disadvantages of dropping that confidence level to 80? Well, our margin of error gets smaller. So the thing is, if we have a smaller margin of error, there's a better chance that we miss the true population proportion, but we're also being a little bit more accurate too. So advantages and disadvantages, no matter what, we have a smaller margin of error. We are less likely to capture an actual population proportion, P, but also we're going to be a little bit more accurate. How large would the sample size have to be to lower the margin of error to 2%? I'm going to keep it at 95% confidence and 45, 55 over n. Start by dividing that. So 0.02 divided by 1.96, you'll have that number. And then we're going to square both sides to get rid of the radical. So we'll take that number squared. So 3 zeros, 104. Equal to, let's see what 45 times 55% are. 2475 over n. That means I'm going to cross multiply, so 0.0104 n equals 0.2475. Divide both sides by our decimal. So this one divided by that, and we should be expecting around 2,377. So a much larger sample size to get it down to a margin of error of 2%. Okay? There shouldn't be any curveballs on tomorrow's quiz. This is, if this is good, you should be well prepared.